Okay. The first question. Sir,
I hope
please
that I
tell
didn't
us.
speak too fast.
No, you didn't. It was super informative. Um, Sir, please tell us about how many times do we have once we have kick, and what are the initial steps to taken when we have kick?
Okay, the first part of the question, if I understand it correctly, how much time we have?
Yes. How many times do we have once we have kick?
Okay, how much time we have? That's a very good question, and actually an excellent question. It depends. It depends on how much over under balance we are, what is the TVD, how deep we are drilling, and also the type of the formation, the type of the formation fluid. For example, if you are 200 psi under balance or 1000 psi under balance, Darcy's equation, right? If you're 100 psi or 200 psi or under balance, less formation fluid can enter the wellbore because delta P has a direct relationship with the Q, with the flow rate, right? The more you are under balance, the more formation fluid at a higher rate, formation fluid can enter the wellbore, so you have less time. The second part is how deep you are. If you are drilling at 1,000 feet or 10,000 feet. So the deeper you are drilling, the more time you have. The third one is what is the type of the formation? Is it gas or oil? Obviously, gas is the most dangerous part. Why? Because gas expands, and when it enters the wellbore, it expands. So basically, it pushes the drilling mud out of the wellbore, making the well even progressively, increasingly more underbalanced. So initially you're 100 psi underbalanced, but when the gas enters, expands, then suddenly you go 200, 300, 400. So the more you go underbalanced, the more formation fluid can enter the wellbore, and the gas migrates much faster than oil and brine. So you have less time. Basically, to answer the question, it depends on these factors. The depth we're drilling, how deep we're drilling, the amount of underbalance we are, the property of the drilling, the property of the formation, how permeable the formation is, and also the property of the formation fluid, how viscous is or how light is, whether it's oil or gas, stuff like that. Did I answer the question? Is it clear for the student who asked the question?
Yes, thank you, doctor.
And the second part, I will talk about that later in the lecture. The proper steps we need to take. Sorry to cut you off.
Okay. And another question. In case of trip, we are at the middle of the kick. Sorry, in case of trip, we are at the middle. If kick happen, then what will be done?
A very good question again. I will talk about that at the very last part of the lecture when I'm talking about the volumetric method, how we can take care of that issue when we are in the middle of the tripping operation.
Okay. How calculate the trip margin?
Good question. The trip margin, basically, we need to calculate the pressure drop due to friction when we are tripping up or tripping down. So we need to calculate, we need to know the speed, how fast we're going to trip in or out. We need to know about the the rheological properties of the drilling fluid we have, and we need to know about the dimensions of drill string and the wellbore. To answer the questions, if if you look at the applied drilling engineering fundamental, this book, on I think chapters uh, chapter 4, page 160, 364, you'll find the formulas to calculate that.
Okay. Another question. Why with all of this kick indicator, the drill did not take his action to shut in the well quickly?
Oh, you're talking about the clip. That's a very good question. We don't know exactly what happened, but probably the reason the blowout happened was the crew were not well trained. So they didn't know what actions they need to take. Obviously, the kick indicators were pretty obvious that kick is happening and is going to become a blowout, but they failed to take proper actions. So either lack of knowledge, lack of leadership, or lack of enough preparation.
Okay. And how can distinct between abnormal and how can we distinct between abnormal and subnormal pressure?
Okay, abnormal and subnormal pressure. They did the distinguish between these two. Obviously, we need to know the pressure. Uh, if we calculate the pressure at any depth and divide it by TVD, and the pressure gradient is below normal pore pressure gradient, we call it subnormal. If it's above, we call it abnormal. How we can discern between these two? There are several techniques. Obviously, we need to know about the geology of the region. Also, seismic data can tell us, okay, there is a possibility of having subnormal or abnormal pressure formation. Well, I'll talk about that more in details in the future slides, next session.
Thank you. And when hydrostatic pressure approaches to bore pressure, drilling speed increases. Why?
Um, okay. This is a question about the drilling bit performance. If you go to the same book I showed you guys, okay, let me. Okay. Basically, what they found out. Okay. Yeah, on page 225, as you can see here, maybe it's difficult. Uh, they plotted the rate of penetration versus the amount of overbalance. Because the more we go overbalance, uh, the cuttings for cuttings become more difficult to get detached from the formation. So the longer it takes the cuttings to get detached from the formation, uh, the slower rate of penetration we get. And basically, it's about uh, the failure mechanism of the rock itself. Instead of elastic, it becomes plastic. So and instead of brittle, it becomes ductile. This is mainly the reason for responsible for the lower rate of penetration.
Thank you, doctor. And we have a last question.
Okay.
If kick is observed and we are increasing the mud weight to stabilize the well, and because of the increase the mud weight we have losses, then what should be done?
Okay, so basically we have kick and loss, right?
Yes.
That's a very complicated scenario. Uh,
It do happen?
uh, Usually it shouldn't happen because uh, if we know the mud window and we drill it based on the plan, we shouldn't fracture the weakest formation, which is supposedly below the casing. Uh, I haven't personally seen any case like that. Uh, but in this case, if they suspect that this might be the case, probably managed pressure drilling is an option. So you have flow and loss simultaneously while drilling.
Okay. Thank you so much. Thank you so much, Professor.
You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby. And twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire.
Answer any questions you may have. Is there any question?
Dr. Hussein, yes, there's a question, someone asking, what is the function of the remote choke valve?
Remote choke valve.
Yes.
Remote choke valve. Uh, choke valve is basically choke valve is basically used when we are going to have we want to circulate the formation fluid out of the wellbore. So the choke valve needs to get open so the formation fluid go through the choke manifold.
Okay, this is the only question we received related to the subject, so you can go ahead.
Okay, so this was the only question. The initial circulating pressure and final circulating pressure, let me talk about them. When we calculate the casing shutting pressure and the pipe shutting pressure, we should know how much pressure we need to establish the circulation, because after doing the calculations, the main goal of the well killing operation is first of all to circulate out the formation fluid, and then to replace the current mud, which is too light to drill that formation based on the incident, to replace that mud with a kill mud, which is heavy enough to prevent the formation from flowing. So initial circulating pressure, the pressure we need to read at standpipe pressure, obviously should be equal to drill pipe shutting pressure, because this is the pressure is required to open the valve. Plus, so by applying that pressure, drill pipe shutting pressure, the valve, the float valve gets open, and after that we can have the continuous circulation. In order to have a continuous circulation, we need to overcome the pressure drop due to friction inside the system, which is drill string, drill bit, and annulus. This is initial circulating pressure. Final circulating pressure is when we have kill mud. So the current mud has been already replaced by kill mud inside the annulus. This is basically the pressure drop due to friction when we have kill mud, in order to have a continuous circulation. Calculate the volume, the drill string and annulus volume is pretty straightforward. So we need to know the volume of the drill string and annulus. These values are needed when we want to perform the circulations, implementing either weight and weight or driller's method. So we need to know how much mud, how much volume of mud, current mud or kill mud we need to pump to make sure, for example, kick for influx is completely out of the wellbore, or to replace the current mud with the kill mud. After calculating the volume of drill string and the after calculating the volume of the drill string, we can calculate the number of strokes we require to replace the current mud inside the drill string with the kill mud, and also the amount of strokes we need to fully replace the current mud with the kill mud. So to generate the kill sheet, I will talk about that in the future session. It's 5, so I'll stop here now. Any more questions?
Thank you so much. Yes, we have questions.
And someone asking about both water and gas and oil kick is undesirable. According to you, which is more dangerous?
Definitely gas, because of the nature of the gas. It's highly compressible and also very low density. So it's much more challenging to handle than oil and brine.
And another one, why the mud is pumped at low rate?
When we want to calculate the drill pipe shutting pressure, because the lower the rate, the lower the change in the pressure, and the lower the change in the pressure, the easier to accurately determine the drill pipe shutting pressure.
Okay. What is the difference between the shear ram and blind ram and their functions?
Okay, but shear ram and blind ram, shear basically it shears the pipe. Blind basically is blind the pipe, so it does not shear it. Both of them are the last resolution, and on a rig we have only one type of, either the shear ram or blind ram.
Okay, let me get this question for you. Someone asking about uh, what is the difference between, not this one. During the kill, if we space out, mean we stop drilling and rotation, is it any chance for the pipe to get stuck because there's no rotation?
Uh, Usually it's very low. The chance is extremely low. However, when you space out, you don't necessarily need to stop rotating. You can rotate and space out, and then you pump. You turn off the pump.
And the last question, which method will the efficient during well killing to increase the mud weight of all the mud system or replace the mud with kill mud?
Which method? I will talk about the well killing method in the next session, hopefully.
Okay. Thank you. Thank you so much, Dr. Hussein, again.
You're very
And
welcome, Maya.
to highlight, this session has been uploaded and will be has been recorded and will be uploaded. So make sure to subscribe on our channel. Hoping you a good day and bye.
Thank you very much. Bye bye.
You're giving me wind and rain.
Is there any question, Maya?
Um, there is just one question.
Okay.
If there is a loss after having a kick, what is the method to apply?
If we have a kick, if you have a loss after having kick,
Yes.
first of all, it's highly unlikely if we have kick and loss, because when kick happens, if we are overbalanced, before kick happening, so we should notice the loss circulation. We should take care of that. And if kick does not happen and we are entering an overbalanced pressure formation and the kick happens, so there shouldn't be a loss basically at the surface. I can't think of any scenario that we have kick and then loss. And then if this happened, it will be underground blowout. And frankly, maybe managed pressure drilling is one solution to this problem. So it will not be normal drilling operation, it should be managed pressure drilling. So we have kick and loss. I mean, flow and loss at the same time.
Okay. Another question is, in case we have lost circulation, what can it result to and what can be done to remedy it?
If we have lost circulation during drilling operation, there's several. Pardon me. If we have lost circulation during drilling operation, several techniques can be applied. One of them is to reduce the flow rates. So basically, we're reducing the ECD to minimize or stop lost circulation, or we can pump LCM materials to reduce or cure the loss issue, or we can go and set cement block. So basically, to cure or take care of the loss zone. These are probably three normal procedures can be done during the neck operation when you're dealing with lost circulation zone.
Okay. Another question. In workover operations, no drilling formation. What kill method is recommended?
Usually, what they do is bullheading. I did not cover that here. I did not cover bullheading here because it's in the workover. But it's bullheading, basically pushing the formation fluid into the formation.
Okay. Thank you so much for this informative webinar. And to highlight, this session has been recorded and will be uploaded on YouTube channel, so make sure to subscribe on our channel. Thank you, Dr. Hussein, again, and thank you all. Stay safe and bye.
You're welcome. Thank you very much.
Bye.
Bye-bye.